My wife is neurodivergent. I'm neurotypical. Many of you have been asking about the research recently that's come out about the cerebellum and how it is different in the neurodivergent brain. So let's talk about that. And I should tell you guys, I have a doctorate in physical therapy. I'm a licensed physical therapist in the state of Georgia. I am always on the hunt for knowledge or interventions that can help neurodivergent people face their particular challenges. I went through the doctoral training because it helps me to critically consume clinical research data and parse through whether or not it's valuable or applicable to the issues at hand. The main article I'm going to focus on, and there are several that I've linked in my bio, is The Basal Ganglia and the Cerebellum in Human Emotion by Jordan Pierce and Julie Perrone, published in June of 2020. The journal that published this is called Social, Cognitive, and Affective Neuroscience. This particular article is a synthesis or review of all of the most recent research in this area, and it brings everything together to update the knowledge base. Really interesting information right from the jump in their introduction. The basal ganglia and the cerebellum traditionally have been assigned roles within the motor domain. I knew that from physical therapy school. We routinely talk about how the cerebellum functions to store automatic movement behavior. But recent research has recognized their contributions to a variety of functions, including affective processing. Specifically, the roles of these subcortical structures have expanded beyond simple motor control to diverse limbic and cognitive processes. Limbic is a reference to your emotional function, including emotional recognition. So many neurodivergent folks have trouble recognizing the emotions of other people or even their own emotions. Reward and error-based learning. We've talked so much about the dopamine reward sense of accomplishment loop when it comes to accomplishing tasks. Your cerebellum is playing a part in this. The reward and error-based learning is not happening the same for people with a neurodivergent brain because the cerebellum and the basal ganglia are not looping the same way as the neurotypical brain. Even further, language, decision-making, working memory, and spatial attention. I mean, there's so much here, guys, that we had no idea the cerebellum was involved with. We always were taught, hey, it's just doing motor learning stuff and that's it. Apparently not. Overall, in the healthy brain, repeated synchronization of cortical regions by the basal ganglia and fine-tuning by the cerebellum strengthen representations of a given response pattern and allow learned emotional responses to be generated more automatically in the future, just as with motor behaviors. If you're not forming habits, the reason your brain is not doing that is because your basal ganglia and your cerebellum are not functioning and looping the exact same way as a neurotypical brain. It's literally a structural difference, y'all. This is huge. As a trained physical therapist, whenever I see the basal ganglia mentioned, the first thing that comes to mind is Parkinson's disease, because the cause of Parkinson's disease is the failure of what are called dopaminergic neurons in the basal ganglia. These neurons don't produce dopamine, and therefore you get all the symptoms associated with Parkinson's disease. It just clicked for me studying this article that neurodivergent people also have trouble with the reward task completion loop. There is no concept or experience of feeling proud of yourself at the end of completing a task. There's no dopamine hit. And so there's no loop that provokes you to continue with your activity. That loop is either absent or it's constantly interrupted by a craving for novelty. This is the first time I've ever seen a connection between the dopamine issues for Parkinson's and the dopamine issues for neurodivergence. I never knew the basal ganglia was also involved in the neurodivergent brain. Considering autism spectrum disorders in more detail, difficulties with social interaction and emotion recognition are common, as are cerebellar structural abnormalities, including the reduction in the number of Purkinje cells in the cerebellar hemispheres. Reduced volume of the posterior vermis also is associated with autism spectrum disorders, although a variety of malformations both within and beyond the cerebellum have been reported. You lack Purkinje cells. And what is a Purkinje cell? It's funny you asked that question. Purkinje cells are a unique type of neuron specific to the cerebellar cortex. They are remarkable and instantly recognizable for their massive, intricately branched, flat, dendritic trees, which, wait for it, give them the ability to integrate large amounts of information and learn by remodeling their dendrites. If you have less of these cells in your cerebellum, there is not nearly as much retention of automatic behavior. You see what I'm saying? So the big takeaway is this. Your cerebellum is not automating stuff. This is why the cognitive cost of doing day-to-day tasks is so much higher, because the day-to-day stuff, the typical stuff that people are doing every day without effort, the neurotypicals, the neurodivergents are using conscious thought to accomplish all these things. You have to think about the step-by-step stuff every single time you do it. It almost never becomes automatic behavior, which would explain why it's so difficult for the neurodivergent brain to not form habits. You can have routines, but that core scripting, just rock solid automated habit, that really just does not happen. I've linked this study in the link in my bio as well as with several others. Let me know what you guys think about all this.